All right, hello, hi. I hope you guys are good. Hope you're well. So we are actually going to be looking at calculus, ne? calculus, and more calculus. Okay, and just to sort of like get us off the footing. Yesterday we were busy here. Okay, we were busy here. This is what we were busy with yesterday. We were looking at exam papers, and so in looking at exam papers, we were answering exam type questions. Okay, exam type questions of this nature, right? So if you look at 9.1, the sketch, all right, below shows the graphs of f of x is equal to negative 3x cubed plus mx squared plus nx. Yeah? Then they say the graph of f passes through the origin. Now you can see that the graph is indeed passing through this point, which we refer to the origin. Okay, that's 0 and 0, and has a local minimum and a local maximum. By local minimum, obviously we mean this point. By local maximum, we mean this point. At 1 and negative 12. 1 and negative 12 is down here, and b, 3 and 0 is up there, respectively. So these are the points that this function is passing through, respectively. Then the first question said, show that m is equal to 18 and n is equal to negative 27. All right. We were actually able to successfully do that yesterday, all right, to show that m is equal to 18 and n is equal to negative 27. How did we do that? We are given the function partially already. Okay, since we are given the function partially already, f of x is equal to negative 3x cubed plus mx squared plus nx. All right, I hope you guys can see that function there. I know it's kind of like, yeah, it's negative 3x cubed plus mx squared. Okay, so because we are given that function partially and we are just omitting the m variable and the m and the n parameter are the ones that are missing, what we then are able to do here specifically is what I showed you we do yesterday, and that is, because we are given the stationary points of the local minimum and maximum, we first derive the function whilst it has the m and the n. So the first derivative of the function, there it is, it's negative 9x squared plus 2mx plus n. All right, then we substitute the x coordinate of the local maximum, right? And then we equate to 0, because remember, we first derive equate to 0, but then substitute the point so that we can be able to get an equation in terms of m and n. So we got equation 1, right? Negative 9 times 3 squared got us negative 81, plus 2m times 3 got us 6m, plus n, which is equal to 0. We then wrote our simplified state of the equation 6m plus n. We transpose the negative 81, we got equation 1 from substituting the x coordinate of the stationary point after deriving and equating to 0. We then do the same thing with the local minimum, the x coordinate of the local minimum, which is 1. Okay, having derived the function initially, we just go ahead and substitute whilst equating to 0 to that first derivative of that cubic function. Of course, we substitute the 1, and because of that, we're able to get negative So negative 9 times the 1 squared, plus 2m times 1 plus n, which is equal to 0. Then we get negative 9 plus 2m plus n, which is equal to 0. We then isolate the expression of 2m plus n, transpose the negative 9, and then we get 2m plus n is equal to 9. That's equation 2, all right? And these two equations in terms of m and n are coming from what? Our substitution of the x-coordinate of the stationary points after deriving the cubic function whilst it is in terms of m and n. We then take equation 1 and equation 2, solve them simultaneously. This is like a grade 10 simultaneous equation where we have 6m plus n is equal to 81 and 2m plus n is equal to 9. We solve these two simultaneously, right? I personally in this situation used the elimination method. You could use the substitution method. That's your equation 1. That's your equation 2. So if we take equation 1 and subtract equation 2, 6m minus 2m gives us 4m. The reason why I'm subtracting is because I can see that the variable n is positive and the variable n here is also positive. So a subtraction of the 2 for the n will lead to 0. Then we have 81 minus 9, which gives us 72. We then have 4m is equal to 72. We divide by the coefficient of m, which is 4 both sides. We get m is equal to 18. After getting m is equal to 18, we substitute m is equal to 18 where? Back into any two of these two equations. Okay, so here in this situation, we decided to go for equation 1, substitute the value of m, which is 18 in equation 1. So 6 times in the place of m, we substitute 18 in brackets, plus n is equal to 81. We're able to solve for what? For n. All right, first, for n, because we already have m. And then we say 6 times 18 gets 108. 108 plus 9 is equal to 81. We transpose the 108, becomes negative 108 on the what? On the right hand side. 81 minus 108 gives us negative 27. There we have it. N is equal to negative 27. So m is equal to 18, n is equal to negative 27, and that's exactly what they wanted us to do in this particular question, and that was to do what? To show that m is equal to 18 and n is equal to negative 27. Nobi, so what was the question? The question was show that m is equal to 18 and n is equal to negative 27 when f of x for the function is equal to negative 3x cubed plus mx squared plus nx. So you have the m and the n, they are unknown, all right? And you are given the coordinates of the stationary point. And the concept here was that you are going to derive the function, take the first derivative of the function, equate it to 0, and then because you are equating it to 0, that means you are focusing primarily where? On the stationary points or the local maximum and minimum. You substitute each point for the derivative of the cubic function. You substitute each point and get two equations in terms of m and n. So that was the concept behind what we were doing. Hence, you get two equations, the first one being 6m plus n is equal to 81, the second one being 2m plus n is equal to 9. And then you solve the two equations simultaneously. Because why? They contain your variables, m and n, which are unknowns. So that's why we're finding ourselves having to use simultaneous equation in a question, by the way, that is cubic functions. Make sense? Okay, see, you said, oh, okay. All right. Beautiful. Let's move on to the next question that follows, because that's where I ended yesterday. So if we go to the next question that follows, you just joined. Oh, okay. All right. So this next question, which is from the same question, but it's just a sub question, The sub question said, explain the difference between. Okay, explain the difference between f of a and f prime a. Okay, which year, guys? This is just, these are, yeah, different year papers. Okay, it's a compilation. All right, so it's a compilation of various papers written in previous years. So to be honest, I don't have a clue what year it is. I just know that I'm just going through the topic of cubic functions within the realm of some of these questions. So what year it is, I don't have a clue. All right, I'll find out when I'm done with the actual whatever. Okay. So the next question says, explain the difference between f of a and f prime a. Okay, so this is the general question, because if you look at this previous, the function itself and the previous question, this is just a general question to check if you understand your concept of f of a, okay, as opposed to f prime a. Okay, not today, Nobisa, because this is a series of cubic functions, and I'm doing the second session of actually exam type questions. So not today. I don't know even if it will be tomorrow, because until I finish the cubic functions, the concept is solidified for those who actually requested it. Then I will not be moving on to anything else until I get that sorted. So optimization, I'm sure, will come along at some point, but for now, cubic functions. So f of a and f prime a, the difference. Okay, do we at least know what the difference is between f of a and f prime a? Most f of a, we know, stands for what? What does it stand for? It stands for the y value. All right, and then f prime a stands for the derivative, or the gradient, as we would call it, derivative or the gradient. Okay, hopefully we know those things, because those are basic things that we ought to be knowing. Okay, f of a stands for the y value. Okay, so when you substitute a, which is the x value, you get a corresponding y value, which is f of a. That is basically f of a. But f prime a stands for the derivative or the gradient. Okay, when you substitute a specific value a, and when x is equal to a, for the first derivative, you are able to get the gradient of that particular function that you had. Okay, so that's the difference between those two. Hopefully I'm clear. Hopefully we are on the clear. Okay, let's continue, because time is of the essence. Okay, so please guys, just one more time, as I said, f of a is the corresponding y value. Okay, when x is equal to a, that's basically it. The corresponding y value when x is equal to a, that's what f of a is. But f prime a is the gradient or the rate of change of f when x is equal to a. Okay, so I repeat again, f of a is the corresponding y value when x is equal to a, because remember, a is in the place of x. So f of a is the corresponding y value when x is equal to a. But f prime a is simply what? The gradient or the derivative, or what we call the rate of change of who? Of f when x is equal to a. That's simply that. Moving right along, 9.1.3. So let's just write that down actually, so that we can see we've answered the question. Okay, the difference between f of a. So f of a, guys, let's just write this down. F of a is simply what? The corresponding y value when what? When x is equal to a, right? While f prime a is the gradient. We say it's the gradient, or we can say the derivative. Sorry about that. Derivative, or we can say the rate of change. Rate of change of who? Of f. Okay, when x is equal to a. So that's basically the difference between f of a and f prime a. F of a, like I said, is the corresponding y value when x is equal to a. That's what f of a is. While f prime a is basically the gradient, or we say the derivative, or we could say the rate of change of who? Of f. When what? When x is equal to a. So that's the difference between f of a and f prime a. Okay, let's move on to the next question, 9.1.3. 9.1.3 says g of x is the tangent to the curve of f of x. What is now g of x? So we were initially talking about f of x, the cubic function. Now all of a sudden here in this question we are being told of g of x, and we are told that g of x is the tangent to the curve of f of x at the point of inflection. So this g of x is a tangent to the curve of f of x at the point of inflection, right? So just to be reminded, we did speak about the point of inflection. The point of inflection is basically where the concavity of our function changes. All right, so if you look at this function, for instance, this is a cubic function, and the way it goes is that it is concave up until a point here, midway the two stationary points, the local minimum and the local maximum. We have the point of inflection, which basically is the one that sort of like dictates where our concave up ends and where our concave down starts. All right, yeah, it measures our concavity, or at least it is able to indicate that point where our concavity changes. All right, so concave up here, and then here point of inflection, concave down. So we need to find that point of inflection, because if g of x is a tangent to the curve of this function at that point of inflection, then it means we need to first find that point of inflection. Because what is the question? It says determine the equation of h of x. All right, now here's the thing. G of x is a tangent to the curve of f of x at the point of inflection. But now we need to determine the equation of h of x. So what is it about this h of x now? Determine the equation of h of x, the straight line that is, oh, here's another concept, perpendicular. Perpendicular to what? Perpendicular to g of x. Right. Now we are really incorporating some concepts here, because now you need to be reminded of what does perpendicular then tell us about the line of h of x in relation to the tangent of g of x. So we need to determine the equation of h of x, the straight line, that is what? That is perpendicular to what? It's perpendicular to g of x. And by the way, this h of x, which is perpendicular to g of x, passes through the origin. So that gives us a point of this particular h of x, that this point of the origin lies on the function or on the line h of x, which, by the way, remember, h of x is perpendicular to what? To g of x. The what? The tangent. The tangent to the what? The curve of f of x, where? At the point of inflection. So a lot to uncover, right? But our first point, where we need to take things here, is we need to first find the point of inflection. Now let us recall, how do we find the point of inflection? Okay, and if you remember what we did yesterday when we went through the conceptual knowledge, when we were unpacking the different aspects of a cubic function, we spoke about point of inflection when we did our summary. And what did we say? There are two ways to find the what? The point of inflection. What are those two ways that we can find the point of inflection? All right. Now, I guess fortunately or unfortunately, it might be that the people that were here yesterday are not here today, but you know what? They will catch up, because the video I will upload onto my YouTube channel so that they can watch this at their own time. So for now, those who are here, if you are here for the first time, well, welcome. Hopefully you follow me. You can also go to my YouTube link, to the link in my bio. Then you can find the link to my YouTube channel, and you can actually hop on there, go and subscribe. People, I need people to subscribe on there and to just support the initiative. So anyways, let's look then at how do we find the point of inflection. Two ways. We can either find the second derivative, then we equate the expression of the second derivative to 0. Okay, very good, Nwabisa. That way we can find the x coordinate of the point of inflection. Or alternatively, another way to find the x coordinate of the point of inflection. Remember that the local maximum, the x value of the local maximum together with the x value of the local minimum, the points of the local maximum and minimum, the x coordinates, if we add the two x coordinates and we divide by 2, that way we find what we call the midpoint, all right, which will give us the x coordinate of the point of inflection. So those are two ways in which you can find the point of inflection. The first way, one of the ways, is to find the second derivative of the function, equate it to 0, and then you will get x. You take that x value, you substitute it back into the original function to get the corresponding y coordinate. Okay? Or you can use the midpoint. Take the x coordinate of the stationary point, the local minimum, take the x coordinate of the stationary point, the local maximum, you add them together, you divide by 2, you get the x coordinate, then you take that x coordinate and you substitute it back into the original function to get the corresponding y value. So let's put that then to practice. Point of inflection. Let's find the point of inflection. Second derivative of x, we equate that to 0. Now let's remember the function in and of itself. If we take the original function, which is f of x, remember, is equal to, the entire function was what? Negative 3x cubed plus mx squared plus nx. But remember, we did get the m value, which is 18, and n, which is negative 27. So now we have the function negative 3x cubed plus 18x squared minus 27x. So we now have a working function. Okay, so let's first derive it. First derivative. If we get the first derivative, what do we get, guys? Take the 3 multiplied with the negative 3, we get negative 9x. The subtraction of 3, we subtract 1 from 3, we get x squared, plus take down the 2 multiplied with the coefficient, we get 36 subtract 1 from the x to the power 2. 2 minus 1 gives us x to the power 1. Minus, take the 1 multiplied with the 27, you get negative 27. The x to the power 1 minus 1 gives us x to the power 0, and we know x to the power 0 gives us 1. So we have negative 27. That's the first derivative. We then derive the second time, but this time round we are going to equate that to 0. Let's first derive though. Take the 2 multiplied by negative 9, we get negative 18. Subtract 1 from the 2, we get 18x. Plus, take the 1 multiplied with 36, we get 36. X to the power 1 minus 1, that gives us 0. X to the power 0, which is 36. So that is the second derivative. We get 18x plus 36. Now we can take that 18x plus 36, equate it to 0. Then what we do, what? Solve for x. 18x is equal to negative 36. We divide both sides by the coefficient of x, which is 18. We get an x value, yes, Gahri. We get an x value, Gahri, of negative 2. But we are not done. We need the y coordinate. So now we take f of negative 2. Where do we substitute it? To the original function, which is negative 3x cubed plus 18x squared minus 27x. So we say negative 3 into negative 2 to the power 3. 18 times negative 2 to the power 2 minus 27 times negative 2. We are substituting x is equal to negative 2 into the original function, which we know is negative 3x cubed plus 18x squared minus 27x. Me and you don't have to bother ourselves too much. We just grab Mr. Scientific Calculator. He can do the hard lifting for us. Okay, let's do the hard lifting using Mr. Scientific Calculator. So negative 3, just put that in brackets. Negative 2 we close. We put the to the power 3 there. Plus what? 18. Okay, let's not there. Move the cursor a bit. Plus, yes, the plus must be down there. Plus 18. We put the bracket. We put negative 2 in brackets, the whole thing squared. Minus 27. We put the bracket. Negative 2. We close the bracket. Then we just check and verify to make sure that all the values that we have punched in are actually in accordance to what we had written down, and we double check again that what we have written down is in accordance to what we would have wanted to write down. We don't want to be making a mistake because we typed in something incorrectly. This is so important, guys, because what you want to achieve is accuracy. You get an answer. All right, is this a plausible answer? 150? No ways. So there's something that must have definitely gone wrong. The question is, what is that thing? Yeah, or did I do something? There's something that we must have done. I'll tell you what it is. There was an error. Where did that error get made? It's not negative 2. Definitely yes. Okay, do you see, guys? So this is the beauty of double checking. Okay, so here you see, when I derived here, I said 2 times negative 2. I didn't say 2 times negative 2. I put positive 18. Bad error. So we say negative 18 there. Okay, because it took me just looking back at what I had previously written and then seeing my error. Negative 18. You see, here, errors can be made. Negative 18. Divide by negative, we get positive 2. So that is all supposed to be positive 2. Okay, and that's a grave error that was made by who? By me. All right. Okay, and this is why it's so important, guys, to double check. Very silly mistake, KG. You can say that again. Thank you for saying that. All right, one that you cannot afford to be making. You cannot afford to be making such mistakes. especially when you are sure and you are sure about what you are doing, but it's just that it's just a silly, really silly mistake. Okay. All right, let's do this again. Negative 3 in brackets. We have positive 2. We cube that. All right. Plus, we have 18 in brackets. Sorry. Move the cursor. Plus, we have 18 in brackets. We put 2. We square that, of course. Minus 27. We put 2 in brackets. Makes much more sense. The negative 6, okay, is the answer that we get. Negative 6. We get an answer negative 6. And when I did type in, I made sure that what I was typing in was 100% correct. So we get is equal to negative 6. That's f of what? F of negative 2. Okay. So there we have it. We have our coordinates 2 and negative 6. That point of inflection makes more sense for the function and the sketch as to where it is. Okay, it makes more sense because you can see if x is equal to 2, it makes sense because on this side of the x-axis, our values are positive. The y value here cannot be greater than negative. It cannot be less than negative 12. It has to be greater than negative 12. So that's why, guys, when I got that answer, I knew something was off. So I had to retrace my steps and just go and check again if there was any error I had made. And because I could see that there is that negative 18x, actual fact, I would advise learners that you make sure you scratch, you write what's correctly. The last thing you want to be doing is giving someone who's marking your work an idea that you were writing positive 18x, whereas it's clear you wanted to correct and say negative 18x, so that this actually then makes sense. Your whole entire working out, derivative, second derivative, equating to 0, solving for x, getting your x coordinate, taking your x coordinate, substituting it into the original function so that you can get the coordinates of the original function. Remember, guys, that the question was not asking for the point of inflection. The question was asking for what? We want to determine the function, the straight line function h of x, which is basically perpendicular to a tangent, which is called g of x. That g of x, we have now just found that point of inflection where g of x is the tangent to the curve at. Okay. So now that we have the point where this tangent is touching as a tangent to the curve at f, the next thing we have a point, now we need the gradient at that specific point. So what do? We know if we want the gradient, then we need to say f prime. Okay, f prime of what? Of 2, which is the x coordinate of the point of inflection. We substitute that x is equal to 2 of the point of inflection at the first derivative. Okay, very important, very important that we do that. And by so doing, this will help us to get the gradient of the tangent, which is tangent of g of x at the point, which is negative 2 and negative 6. So by substituting, we are able to get the gradient of the tangent of g of x at point 2 and negative 6, that point of inflection. So let's do this. F prime of 2. What was the function of f prime? It was negative 9x squared. So we say equal to negative 9. In the place of x, we substitute 2. Okay, squared plus 36, we substitute 2, minus 27. All right. Okay. So we are going to now substitute and then see what values do we get. So once again, we grab our calculator. We just simply say -9 brackets, we have 2, we close, squared, plus 36, we close, 2, we close, minus 27, we say equal, we get 9. So f prime of 2 is equal to 9. Therefore, that means the gradient of g of x is equal to 9. All right, that's equal to 9. Now, remember, what did they say in this particular? They said g of x is the tangent to the curve of f at the point of inflection. Now, we need to determine the equation of who? Of h of x. The straight line that is perpendicular to g of x. So what do we know if the straight line is perpendicular to g of x? That means if h of x, that line, is perpendicular to g of x, that line, then we know that the product of the gradient of g of x and h of x should give us what? -1. Perpendicular lines, guys, have a product of the two gradients, which will give you -1. Now, this is something that you guys learned in grade 10. In actual fact, you learned it in grade 9 when you did straight line functions. You then further solidified the concept when you did analytical geometry in grade 10. In grade 11, it was revised again when you did analytical geometry. All right. So as a grade 12 learner, you should be knowing that the relationship of perpendicular lines is that the product, meaning the multiplication of the gradients, should definitely give you -1. So remember, you have the gradient of g, you want the gradient of h. So you're going to say the gradient of h times the gradient of g, which is 9, is equal to -1. You make the gradient of h the subject. That means you are going to divide both sides by 9. You cancel here, which means the gradient of h of x is equal to -1/9. So you now have the gradient of h. What else were you told in the statement of the question? All right, above. What else were you told? You were actually told furthermore, all right, and please take note, you were also told that determine the equation of h, the straight line, that is perpendicular to g. We've used the idea of perpendicular to get the gradient of the equation of h, and passes through the origin. We can't find the equation of a straight line unless we have two things. And what are those two things? The gradient, which we have, and a point. Remember, if h of x passes through the origin, that means we know that h of x passes through the point 0 and 0. All right. So then we go ahead and we write y minus y1 is equal to m into x minus x1, which is very simple. We substitute the gradient, -1/9. We substitute the point 0, 0, which is y minus 0 is equal to x minus 0. We then distribute and solve, guys. We distribute and solve for the equation. So y is equal to, that 0 just simply becomes 0. We distribute the -9 or -1/9. -1/9x, -1/9 times 0 is basically 0. So the equation of h of x is equal to -1/9x. That is basically what they wanted us to calculate. And it is really as simple and as straightforward as I have shown you the equation to find it is. Okay. All right. So guys, this is how we were able to answer the question that we were asked from the question that I had shown you. Okay. Yeah. So yeah, if you guys have any questions, then please do ask. But if not, then not. I just wanted to show you one more time. The question that we were answering was this one. Okay. Yeah, we were asked basically to find the equation of h of x. We're given a function f of x, which is here. Then we were asked basically, we're told that g of x is a tangent to the curve of this function, but we were told specifically at the point of inflection. And then we were told to determine the equation of h of x, the straight line that is perpendicular to g of x. Remember, g of x is the tangent to the curve of f. We're told to determine the equation of h of x, the straight line, which is perpendicular to g of x and passes through the origin. So step by step, what we did do when we were answering this question is that firstly, we found the point of inflection of the what? Of f of x. How? We found the first derivative, firstly, of f of x. And then we found the second derivative of f of x. We then equated that second derivative to 0, solved for x, got x is equal to 2. Took the x is equal to 2, substituted it into the original function of f of x, and then we were able to get the corresponding y value, which is -6. That meant we had a point, which is 2 and -6, and that 2 and -6 is the point, basically, the point of inflection where the tangent g of x touches. We then went ahead and we substitute x is equal to 2 into the first derivative of f of x so as to get the gradient of the tangent g of x at that point. When we substituted that x value of 2 into the first derivative of the function, the cubic function, we got a gradient of 9. That is basically a representation of the gradient of g of x. Because we were told that g of x is perpendicular to h of x, we then summoned our conceptual understanding of what we understand about about two perpendicular lines, and that is the gradient, the product of the gradient for two perpendicular lines is equal to -1. Knowing the gradient of g of x, which is 9, and multiplying with the product of h of x, equating it to -1, we divided both sides by 9, after which, dividing both sides by 9, we got the gradient of h of x, which is -1/9. Then remember, in the statement we were told that this straight line h of x, which is perpendicular to the tangent of g of x, passes through the point 0 and 0, which is the origin. In fact, the language used was origin. We need to know that when they say origin, they are basically meaning 0 and 0. 0 for x, 0 for y. We then used our equation formula found in the formula sheet, which is the formula we use to find the equation of a straight line, having the gradient, which is -1/9, and having the point where the straight line h of x passes through, which is 0 and 0. We substituted y1 and x1 as 0, substituted m as the gradient, distributed, transposed, got y is equal to -1/9x, which is basically h of x, which is the function, the equation of which is -1/9x. That is how we answered that question. Done and dusted, clear as daylight. All right, clear as daylight, and clear as can be. Where do we see g? My leader, you see g by making sure that the first derivative, if you are substituting the x coordinate of the stationary point, will give you, or if you are substituting a particular x value where a tangent touches will give you the gradient. You need to substitute a specific x value in the first derivative to get the specific gradient at that point. All right, so that is the concept there. Yeah, please don't mix concepts. Okay, let's continue. Let us continue. The next question which they ask here is, for which values of x will f double prime x be greater than 0? F double prime x greater than 0. What does this even mean? For which values of x? They want us to find the x values where the function is concave up. When they say f double prime x greater than 0, they are basically saying, where is the function concave up? So you go there to the function, you ask yourself, where is the function concave up? And so they're saying for which values of x. So guys, if you have f double prime, whether it's greater than 0 or less than 0, greater than 0 for f double prime means concave up. F double prime less than 0 means concave down, right? So your specific then focus or attention of x value is you focus on the x value of the point of inflection. That is your frame of reference as you consider for which x value, all right, for which values of x is f double prime x greater than 0. So they are asking you, in other words, where is the function concave up when they say f double prime of x greater than 0? And the x value to consider as you look to write your answer is the x value of the point of inflection, which you found. You found the x value of the point of inflection for this function. Okay, somewhere here, the x value is 2. Okay, 2 and negative 6 was the actual coordinates, but the actual x value is 2. So now you're asking yourself, where is the function concave? Remember, I said f double prime greater than 0 means where is the function concave? Up. Which values of x show you the function being concave up? So here, guys, from here, from infinity to here, that x value, the function is concave up. This is where the function is concave up. Because from here, going this side, it's concave down. So when a concave up means smiley face side up, right? So the answer, simply put, it's where x is less than this side of x is equal to 2, is where x is less than 2. That's where the function is concave up. In other words, those are the values of x where f prime x is greater than 0. F double prime, sorry. F doubled, because this is double. So the minute they say double prime, they're talking about, and it's greater than 0, they are asking you where is it concave up specifically. If the question had said f double prime x less than 0, then they are asking you where is the function concave down. And if they were asking you that question, where is the function concave down? It's where x is greater than 2. In other words, this is where the function is concave down. X greater than 2. When x is greater than 2, the function is concave down. But when x is less than 2, the function is concave up. Okay, I hope that's clear for all of us there. Yeah, so as I said, the minute they say f double prime, to consider x values, which x values are considering? The x value of the point of inflection. That's the x value you must consider. Then you look at the function. On which side? Okay, this side we are concave up, smiling. That's concave up. From x is equal to 2, from this side of x, x is greater than 2, we are concave down. Right, I hope we are clear there. I hope the explanation has been adequate and you feel it's enough. Let's go on. Move on to the next question that we find in the question paper. Here's the next question. Okay. 9.2. Okay, can we see 9.2? Is 9.2 seeable? The function t, which is defined by t of x, is equal to 2x cubed plus bx plus c, and has the following properties. T of -3 is equal to t of 3 is equal to t of 0, which is equal to 0. What are these, guys? Can I ask you? Can anyone in the comment section tell me what are these? T of -3, which is equal to t of 3, which is equal to t of 0, is equal to the value 0. What are all of these? 1, 2, 3 equated to 0. Very good, Sfundis. Okay. These are the values, -3, 3, and 0. These are the values that are found on the x-axis. And therefore, the equal to 0 is a representation of the x-axis. Because where y, this here is your y value. This here, -3, 3, and 0 are your x-intercepts on that x-axis. Because remember, the x-axis, that is the line where y is equal to 0. These are the input values. In other words, these are the roots, the x-intercepts. -3, 0, then 3. In that order, if you're looking from left to right of your function. Let's come down here. T prime -1/5 is equal to t prime 1,5, which is equal to 0. What is this, guys? The second bullet point. What are those? What do we refer to these as? What are those? T prime -1/5 is equal to t prime 1,5 equal to 0. What are those referred to? The -1, t, -1,5, and t 1,5. Okay, derivative. Okay, definitely derivative. But for our function, what do we refer to these as? What are these specifically? This and that. The -1,5 and the 1,5. What are they specifically? The -1,5 and the 1,5. Okay, the turning point, specifically what? The x-coordinate of the turning point. And obviously this is local, minimum, or maximum. Then they are saying use this information to draw a neatly labeled sketch graph of t. And take note what they say. Without solving for what? For b and c. They want a neatly labeled sketch graph of t without having to solve for who? For b. And for who? And for c. Right? So here's another clue. Do you see t of x? See the value of a? The value of a is 2, right? This is the other interesting thing. The value of a, the coefficient of x cubed, is 2, and 2 is positive, right? So just want to write down this information. T of x is equal to 2x cubed plus bx plus c. We are then further given t minus 3 is equal to t into 3, which is equal to t into 0, which is equal to 0. Then the second bullet point is t prime negative 1 comma 5 is equal to t prime 1 comma 5, which is equal to 0. Okay, so we already established that this and that, this obviously represents our x-intercepts. This here represents our x-coordinates of the stationary points. That we have basically accepted because you guys cooked it as such. Okay, so we are also in the know-how that because a is greater than 0, we are expecting to be sad and then smile only at the end, which means concave up is at the end because a is equal to 2, which is a greater than 0, which speaks to the shape of the function. So the rough sketch can be drawn, and it can be drawn very well. Very, very well. Okay, very, very well. So let's draw. Okay, actually, I've got a ruler. We have a ruler this time round. So let's do justice. Okay, let us do justice. We have a ruler. Stop doing injustices. Okay, remember here they just said use this information to draw a neatly labeled graph of t without solving for b and c. Okay, so this is gonna be just a sketch graph without having to solve anything. All right, so we are just complying to what they've said so that we can be pleasing to them as to how they asked us to do things. Okay, so first things first. All right, if you look at the equation even, let me show you something that you might find also interesting. Because someone said, what about the y-intercept? Look at this equation. All right, 2x cubed plus bx plus c. We are told it has the following properties. Okay, yeah, so yeah, we are just going to be really as rough as feasible. So let's look at minus 3. Minus 3 is here. Okay, 0 is here. We have a negative 1 comma 5, all right, which is like midway. Then we have 1 comma 5 as well, which we were told. Okay, and then we have 3 as well, which we were told about, 3 and 0. Okay, so this 3 and 0, we're just gonna be without. Remember we said the shape. So if this is our negative 3 first x-intercept followed by this x-intercept, then concluded by that one, that means, remember the shape, we have an idea of the shape, so that means we are going to go up like that, and obviously we're going to turn somewhere which is exactly at the turning point, because remember, negative 1 comma 5, first derivative equated to 0, that is our turning point there. Then remember, we have this t0 is equal to 0. So that is a y and x intercept, because 0, 0 is the origin. Negative 1 comma 5 is another stationary point, x coordinate of the turning point. And obviously, given our shape, it means we are going to be turning there and then going back there. So let's do this, finish it off. We turn, we go down there, we turn, we go up there. Okay. And this is given the shape that basically we knew should come about because a is equal to 2. Okay, so this is 0 and 0. That speaks to the y and x intercept. All right. Then here, all right, we don't have the specific y coordinate, but we can be fine with that point because it aligns with the x coordinate of the proposed turning point. Likewise here, okay, we can be fine with that. Okay, and then obviously this is 3 and 0, in as much as this is negative 3 and 0. We can't really give the specifics of the turning point, so this is like a rough, neat sketch really, because we were specifically given an instruction to do what? We cannot solve for a and b. So that is our rough sketch, and I think that is as best as we can get. 1 comma 5, of course. All right, I mean, I would probably do that, and then the 1 comma negative 1 comma 5, you know, just so that they know fully well that that is our x coordinate, but we don't know the corresponding y value. And I think the shape is really, really straightforward, on point. Then what can we do? We can go ahead and just label this as t of x, so that they know that we know that that is our function, t of x. Okay, I think that's the best we can do under these circumstances, right? So guys, a very interesting question here, but at the end of the day, there was a way to do it. So that's why you have to have the knowledge at least. Okay, have the knowledge at least. Okay, very important knowledge to have. Very, very important knowledge to have. Okay, all right. Let us move on and see if we can do other questions. Okay, let's come here. Okay, Free State, this one, Free State province paper. Free State. So we just did Eastern Cape. That was Eastern Cape question paper there. Now Free State, right? And we're going to do various provinces, guys. You know, Gauteng province, we have KZN, Western Cape. So yeah, we're going to be doing all of these. Hopefully we can then glean a lot, you know. Examiners set, you know, sometimes different things. So it's always nice to cover the provincial papers. Remember, even in the upcoming June papers, most of you will be writing a specific provincial paper from your province. Okay. So let's come here now. The equation of the cubic function f is given as f of x is equal to negative 3x cubed plus 15x squared minus 21x plus 9. Okay. This is the equation of the cubic function f. It's given as f of x is equal to negative 3x cubed plus 15x squared minus 21x plus 9. 8.1 says determine the x and the y intercepts of the graph. Now I want you guys to share with me what are the various ways in which you guys find the x-intercepts. Okay. Because I'll tell you this, that for me, you know, nowadays, you know, I would actually love to do the following with this function. Just go to let's say mode. Okay, then press 3 for table. Punch in this function, all of it. Okay, punch it in, all of it. So we have negative 3, right? X cubed. So it's alpha x, then it's the, it's negative 3. We have alpha, then the x cubed plus 15x minus 21x plus 9, right? So I'm looking at the last constant, which is positive 9, and I'm thinking to myself, what are the factors of 9? Okay, when I think of factors of 9, all right, what are the factors of 9? Think of factors of 9. I'm thinking of 1, 3, 9. Okay, 1, 3, 9. So what would be nice here is if I could actually type in this function. Okay, as I have it there, it's done. I can press equal. Let's skip g of x. Then we're going to say start. Where do we start? Let's start maybe at negative 3, right? Because 3 is a factor of 9. Okay, so let's start at negative 3. And then we say equal. And let's end at positive 3, because 3 is a factor. Did I do a mistake? How? Okay, let's do it. It's okay, let me type it in one more time. If you guys say I did a mistake, the last thing I want to do is to have the function typed in incorrectly. So let's do it one more time. So you would have said, let's just go back to comp, say mode, then 3 table, right? Then let's say, oh, I didn't put the negative, did I? Negative 3 alpha x, we can put the cubed, all right, plus 15 alpha x, we square it, minus 21 alpha x plus 9. G of x we just skip, equal, we say start. So as I said, guys, okay, maybe let's push it back. The question is, if I said negative 9, let's just say negative 9 to 9. Since the highest factor is 9, let's say just say negative 9. See if it will accommodate that. Let's press equal. So we started negative 9, equal, we ended 9. Step 1 is fine. Okay, and there we have it. We are going to look at our x values, and if we get any x value giving us a 0, that means we have a factor that we can actually register for this cubic function. So let's go down and we are going to check if there are any x values that are giving us 0. So we go down. So negative 9 doesn't, negative 8 doesn't, negative 7 doesn't at all. We go down. Negative 6 does nothing. Negative 5, no. Negative 4, no. Negative 3, nope. Negative 2 does nothing. Negative 1, 0, 1. Ooh, we have 1 doing something. So that means if x is equal to 1 is a factor, right? If x is equal to 1 is a factor, it means x minus 1 is equal to 0. So we have x minus 1 as one of our brackets. Okay, that will work out. If x is equal to 1 is, a value that we substitute into the function to get 0, x minus 1 is definitely a factor. Okay, let's go down our calculator and see if there are any other more x values that give us 0. Ooh, 3 does the same as well. 3 goes into 0. We are working. X is equal to 3, which is x minus 3 is equal to 0. That means x minus 3. Okay. All right, that's good. But then we are missing something, another bracket equated to 0. And the question is, what is that missing binomial? So I can quickly check what it is actually. So if we distribute this x times x, x times negative 3, negative 1 times x, and negative 1 times negative 3, x times x gives me x squared, x times negative 3 is negative 3x, minus 1 times x is negative x, and then negative 1 times negative 3 is positive 3. Okay. We have x squared minus 4x plus 3. And then I'm thinking to myself, now to get the function that I have, which I'm concerned about, which function is f of x is equal to negative 3x cubed plus 15x squared minus 21x plus 9. Okay. What would I have to multiply x squared with so that I can get the number negative 3? What would I have to multiply x squared with to get negative 3? Obviously, that would be negative 3x. Then what would I have to multiply 9 by? Okay, what would I have to multiply 3 with to get 9? So that is positive 3, by the way. So I'd have to multiply positive 3. Multiply by positive 3. Okay. So that's what I have there. Here. Okay. That's what I have there. That's what I have there. So I have x squared minus 4x plus 3 into negative 3x plus 3. And by the way, this can be then rewritten as x minus 1 into x minus 3 into negative 3x plus 3. But of course, you can take out the negative coefficient, which is negative 3 for all the brackets. Okay, and then you write x minus 1 into x minus 3 into x minus 1. Because remember, if you took this negative 3 back to the x, you get negative 3x. If you took this negative 3 back to the negative 1, you get that positive 3. So that works out. So these are my original brackets. So I can take this negative 3 into x minus 1 into x minus 3 into x minus 1 and equate it to 0. Now to find the x-intercepts this way, then of course letting y be equal to 0, because this here bracket, factors of brackets that are factors, represents this entire cubic function. Okay, it's negative 3 into x minus 1. X minus 1 repeats, x minus 3 equal to 0. So I want to find the x-intercept. I let y be equal to 0. Then I solve. So that will mean I will get x is equal to 1 or x is equal to 3. Those are my x-intercepts. So this is a method that you could use. Okay, it's a method that you could use to get the x-intercepts. And I'm saying that, well, if you don't have a method, this is a method that you could use. But there are many others, guys. There's varying methods. Those who have the white calculator, you guys even have that calculator to basically help you get those answers quickly. So they said determine the x and y intercept. They don't want the coordinates, they just want the x and the y. So x is equal to 1 or x is equal to 3, that's the x-intercept. Then if we want the y-intercept, we let the x be equal to 0. So f of 0 is equal to negative 3 into 0 cubed plus 15 into 0 squared minus 21 into 0 plus 9. So f of 0 is equal to 9. Therefore, that means the y int is equal to 9. So whilst the x-intercepts are 1 and 3 respectively, the y-intercept is equal to 9. Okay, that answers that first question, because the first question, what did it ask for? It wanted the x and the y-intercepts. And this method that I used helped me with that. Okay, help me with that. Okay. Yeah. 8.2. Determine the coordinates of the turning point of f. That should be straightforward. I want us to determine the coordinates of the turning point. What do we do when you want the coordinates of the turning point? Mawufuna a turning point, you first derive, equate to 0, substitute x to the original function. They want the coordinates of the turning point. So you must first, okay, so let's just write down the function again. F of x is equal to negative 3x cubed plus 15x squared minus 21x plus 9. Okay. So what do we do first? We first derive negative 9x squared plus 10x minus 21. Then we take this, we equate to 0. So negative 9x squared plus 10x minus 21 is equal to what? Equal to 0. Now I know at this stage most of you use the quadratic formula. That's fine, no problem to use the quadratic formula. You are not doing anything wrong if you were to basically approach the calculation in that fashion. You would be 100% correct. And of course, when you do the correct thing, I would award you the marks that are due to you. Not hold back anything, because maths is maths, right? Mathematics is mathematics, so no fight. Bit of a mistake there. Did you see the mistake we made there? Negative 9x squared, 15 times 2 can't be 10. Okay, it means I saw 15 instead of saying 5. Okay, so these are errors, guys, that we need to be mindful of. See what a big difference that would make. And if we are frustrated and we don't get to the answer, it would only be because we made a mistake, a careless mistake, that is, one we can't afford to make. Okay, so highest common factor, negative 3. So that gives you 3x squared minus 10x plus 7 is equal to 0. Then 3x into x minus 7 plus 1 is equal to 0. You don't use quadratic. You can use a quadratic formula. Okay, remember, you can use quadratic formula. It's just that I know how to use trial and error, and the numbers seem to pop very well. You could use a quadratic formula if you really feel like it would just waste your time to do trial and error or to use any other alternative method. Thank you, Science Genie, for the you awesomes. Really appreciate it, buddy. Thank you, thank you. Okay, then if we have the x-coordinate of the turning point, what's left now is to substitute these back where? Into the original function. You all remember? It's a negative and a negative, sorry. See, big mistake there again. It's a negative times a negative that gives you a positive. So negative 7x minus 3x, that gives you negative 10x. So that works out now. I have negative, negative. So x is equal to positive 1. So x is equal to positive 1. I substitute into the original function 3 into 1 times 3 plus the 1 to the power 3 times 15 into 1 to the power 2 minus 21 into 1. Thank you for the heart, me Science Genie. Plus 9. Take your calculator, you simplify it. It should lead you to f of 1, which is 0. So that means we do have a turning point, a stationary point, which coincides with the we have a turning point that coincides with the x-intercept. Okay, that's very common. F of 7 over 3 is equal to negative 3 into 7 over 3, the whole thing cubed, plus 15 into 7 over 3 minus 21 into 7 over 3 plus 9. Do the same thing. Okay, just want to show you guys the practicality of your calculator. Yes, we have no other way, my guy. Still on calculus all the way. Yeah. Sorry. Comp. So it's negative 3, 7 over 3 to the power cubed plus 15, 7 over 3 minus 21, 7 over 3 plus 9. Okay. Then you guys confirm and just verify, you know, if whether this answer is plausible or have they really gone south. Oh my soul, very. I mean, it's like started at half past already. So you're very late. Did you fall asleep or something? Oh, I dare not ask. Yeah, I figured. No problem. You're gonna always watch most in the other place. So negative 3 into 7 over 3 cubed plus 15 into 7 over 3. We forgot the square there, that's why. I was wondering, something was wrong. 7 over 3 squared. Yeah, 7 over 3 squared. We forgot the squared even when we wrote it out. Minus 21 over 7 over 3 plus 9. You see, so it's good to write these things out so that you can see them. So you see, now we can see everything. Now we can go ahead and press equal. You see now, 32 over 9. 32 over 9. So that means f of 7 over 3 is 32 over 9. So our coordinates for the turning point is 7 over 3 into 32 over 9. Okay, that's our turning point. That's our stationary point, or our local max and minimum. Okay, you would have thought, so 1 and 0 is the first and the first stationary point, and then 7 over 3 and 32 over 9 is the second. It's the second stationary. And remember that the question was very clear about the fact that having determined x and the y-intercept of the graph, determine the coordinates of the turning point of f. Now we need to, at 8.3, sketch the graph of f, clearly indicating the intercepts with the axes and the turning point. Alright, so let's do that because we are being asked to do so. It's always proper to follow on and follow through so that we have a good idea. So let's do this. Let's use a pen and also then apply ourselves here. So let's try and at least stay within. Okay, so what do we have here? First and foremost, we have gotten our x-intercept and our y-intercept. So let's just go back a little bit. We've gotten those values, remember? We did. Our x-intercept, we got x is equal to 1, x equal to 3, y-intercept is 9. So we have 1 and 3, which is the x-intercept. Right, x-intercept is 1 and 3, and the y-intercept is 9. So let's go ahead, try and sketch a bit higher than this. So 9 is there. So x is equal to 1, right? X is equal to 1. So we have 1 here, and then x is equal to 3. We have 3 there. Okay. Then, of course, we have our stationary points. 1 is here, the stationary point, and then the other 7 over 3, 3, 6. So that's like 2 and a third. That's just over 2. So 1, 2 and a third, let's say. So it's x is equal to, no, sorry, 2 and a third. 1, 2 and a bit. So that's 2 and a third. Then the corresponding y value is 32 divided by 9. 32 divided by 9, press SD. Say equal SD 3,555. So the corresponding y value 1, 2, 3, 3,5. So let's just say that's 32 over 9. So with the 2 combined, that is here. And then the x-intercept, which is x, 3 and 0. Okay, remember, we did get the x-intercepts. we did get the x-intercept. We got x-intercept, which is 3, and the other one was 1, which was also a stationary point. And then, of course, we did get the coordinates, as you can see, of our TP, turning point. Okay. So there we're going to sketch. Look at this. We're going to sketch this now. Comes down like that. Turns. Okay. 0 and 9. 1 and 0. 7 over 3 with 32 over 9. And then 3 and 0. We label the function. So this is regarded as, what function is this? Is this f or g? This is f of x. Okay, which negative 3x cubed plus 15x squared minus 21x plus 9. So that's our function. Sketched, nicely drawn, no hassle. Okay. Yeah, and as I said, please consult your respective teachers pertaining to whether the point of inflection in a sketch should be drawn or not. Okay. Someone is asking what's the best way to study Euclidean geometry. Use the textbook, especially like new mind action series or new mind action series. And what you do then is you go over it, you learn it, and then try and make sense with what you've learned, so that you can have an understanding of what it is that is there. Now let's move on. Next question. We sketched the graph clearly. The next question says, for which values of x is f prime x greater than 0? Okay. So for a question that we had, there was a question that we had done where they said they want for which values of x is f double prime greater than 0. And remember, what did we say about f double prime greater than 0? We did indicate that when they say f double prime of x greater than 0, that means the function, they want us to find out from left to right where the function is concave up. And by concave up, I explained that concave up is when you have a smile. Concave down is where you have a sad face. So remember, f double prime greater than 0 means where is the function concave up? Okay, so if we can just trace back again, that's f double prime, right? But that's greater than 0. If f double prime is greater than 0, okay, remember, concave up is here, but we are held by the point of inflection, because point of inflection shows where the concavity of the function changes. So for instance, concave up, then from this point onwards it's concave down. So concave up, it's where x is less than 2. When x is less than 2, the function is concave up. In other words, f double prime is greater than 0. But had they asked f double prime less than 0, then we would have said x is greater than 2. That's concave down, because f double prime less than 0 means concave down. So please guys, do not mix the double prime with what we are looking at now. Do not mix the double prime with f prime. This here speaks to where is the function greater than 0 increasing, because the question is saying f prime of x greater than 0. So that speaks to where the function is increasing. So everywhere where the function is increasing, you need to indicate. And then they want the x values. So unlike f double prime, where you look at the x values of the point of inflection, here with f prime, we are looking at the x value of the stationary point or local maximum, the x coordinate of the turning point, stationary point, or local maximum minima. Okay. So for this function, for this particular question, there is the function I've sketched it. So I just want to know where is the function increasing. So here, the function is decreasing up until this stationary point. From here to there, the function is increasing. That's between 1 and 7/3. But then from there, it decreases again. So if I'm answering this question, for which values of f prime x greater than 0 is the function what? Yeah, is f of x greater than 0. So that's where it ends. For which values of x is f prime x greater than 0? In other words, where is the function increasing? So as I said, or as I need to now say here for this specific sketch, because they are asking for this specific sketch now. For which values of x is f of x greater than 0? Okay, Presh, I can see your answer there. Okay, we are increasing here, so definitely. Okay, definitely. So x, you can say x is an element if you wanted to. 1 to 7/3. 1 to 7/3. Or you say x is greater than 1, less than 7/3. Now, these are two ways to write the same answer. Okay. One way to write the same answer. Okay, is it making sense, guys? Is it making sense, guys? I hope it is. Okay. All right. So please, guys, please, if they had said f prime x less than 0, then we would be looking at where the function is decreasing. Okay. Sifundo, if you use the point of inflection, you are very wrong if you use the point of inflection. Because remember, you mean use the point of inflection as in, like, say 1, 2, the point of inflection. So you write two answers, 1 to wherever the point of inflection is, and then from that point of inflection to 7/3. All right. And I mean, yeah, you're just complicating life by doing that, to be honest, because you're going to have to say 1 to whatever the point of inflection is, and then that point of inflection to 7/3. Just write once, man. Okay, please listen to the counsel, right? Because you don't want to be wasting time and staying in a question longer than necessary. What you want to do is interpret this quickly, and then because you know it's f prime, not double, but f prime, you know your focus is on the x values of the stationary point. Okay, that's all. Where is it increasing? Where is it decreasing? All right, x values of the stationary point. But then, right, if they say f prime less than 0, then obviously, you know, that's where the function is decreasing, and you would do accordingly, utilizing the stationary points. Okay. Ooh, the next question. What is the next question? Where is the next question? Why can't I seem to find the next question? These questions, the people's favorite question. This one is saying, for which values of k will f of x equal to k have exactly 3 different real roots? Okay, for which values of k will f of x equal to k have exactly 3 different real roots? Let me allow you guys to answer that question. I don't want to intervene just yet. I want to see what you guys glean from this. I'll explain in the event that people are really super lost. But they are asking for which values of k here in this function will f of x, this is f of x, will f of x have exactly 3 different real roots? Where? Okay, I'm going to mute my mic and give you guys a chance to Okay, so there, guys, you know, remember this was the question. Okay, here, yeah, that was the question. For which values of k will f of x equal to k have exactly 3 different real roots? So my daughter there, my precious daughter, answered the question so well. Right? Hopefully you guys can see that response of hers. Okay, I think that response of hers, k greater than 0 but less than 32/9, sorry. Okay, that response is 100% on point. That is the response that is basically 100% on point. All right, very good. Because you nearly yourself butchered it at first, didn't you? You saw most. You nearly butchered it because at first you wrote 1, and I was like, for which values? But then my daughter got it right there at the end. Right. Okay. So yeah. Let us just explore this question. So this question, guys, is very basic, very nice, very enjoyable question, if you ask me. Okay. The interpretation of the question is as follows: for which values of k will f of x equal to k? Right. So remember, f of x means what? It means y, right? And so y is equal to k. This speaks to a horizontal line where we have a constant. Okay. So what you then do is you are actually comparing y values, and you are checking your y value of the turning point, right? That can represent k, because remember, y is k and k is y, right? So if we are talking about the y values, it's as though we are talking about the k values. But then they are asking us where, for which value of k will f of x equal to have exactly 3 different real roots. Yeah. So we always make sure first and foremost that in the given f of x, the k is on the other side. If it's not, right? Yeah, okay. In the event, let's say they had given me f of x minus k is equal to 0. My obligation is to take that negative k over so that I have f of x is equal to k. I can then judge and gauge, okay, my k value, because k is the same thing as y. All right. Now remember, if it had been, let's say, for which values of k will f of x plus k is equal to 0, I would have transposed it, right? For which values, if they had said for which values of k will f of x plus k equal to 0, I would have transposed the positive k to the other side, right? Then I would have had it in my head that, okay, y is the same thing as negative k. But still, I compare my y values. Now, when they say 3 distinct real roots, guys, here's something to note. I want to do something here. If I took this green and I drew a horizontal line just below the turning point, right? All values of y that are less than 0 give me one distinct real root. And the one distinct real root I am talking about here, guys, is this one. This is when y is less than 0, or we can say this is when k is less than 0. For a situation where we are saying for which values of k will f of x equal to k have, let's say if they had said have exactly one real root, then we would have known that you can see most that this horizontal line cuts the function only at one place. That's one real root. When we cut at one place with a horizontal line, that's one real root. So everywhere below y is equal to 0, everywhere, look, cutting once, we cut once all the way as we go to negative infinity. So anything y less than 0, or in other words, anything k less than 0, that means below the x-axis, everything shows exactly one real root. Now, exactly on the x-axis, in other words, where k is equal to 0, how many real roots do you see when k is equal to 0? Okay, can I just see in the comment section? So below the line y is equal to 0, which is y less than 0. In other words, k less than 0, we have 1, exactly 1. What about on the line, the x-axis, in other words, where y is equal to 0? Remember, y is equated to k at k is equal to 0. How many real roots do we have there? Yes, Presh, we have 2. Exactly here, we have 1, 2, exactly 2, right? And that is basically not the only place where we have exactly 2. Let us backtrack again. We have exactly 1 where k is less than this y value of the stationary point. We also have exactly 1 where the y value, where y is greater than 32 over 9. In other words, where k is greater than 32 over 9, because we said k and y pretty much the same thing. So we would have 1 up where k is greater than 32 over 9. We would also have 1, exactly 1. I want to get. But at k is equal to 32 over 9, exactly here, we back at 2. So there are 2 exactly on this horizontal line where it touches the turning point, and there are exactly 2 on this line where the local minimum is being touched. So k is equal to 32 over 9 is exactly 2. K is equal to 0 here is exactly 2. K less than 0 is exactly 1. And k greater than 32 over 9 is also exactly 1. But 3, where do we have 3? I'm going to use a different marker just to indicate where we have 3. Okay, so let's do, so green means 1, right? I just wanna, okay, everywhere. I mean, literally, we could put a line everywhere, but green means 1, green means 1. K greater than 32 over 9 is 1. K less than 0 means 1. Okay, I'm going to use a different mark. Let's just use red for exactly 2. That is that k is equal to 0. That's exactly 2. And where else? At k is equal to 32 over 9. That's exactly 2. So green means exactly 1. Red means exactly 2. Then, of course, we have exactly 3, which is the pink. Actually, let's see if I can find another. Yeah, okay. It doesn't seem like I have any other further colors. Man, and I thought I had like blue or something. I don't have blue. You're watching this because you love maths. You are a maths absurd. You are a maths junkie. That's why, Tyreek. Okay, so this is exactly 3. 1, 2, 3. So everywhere in between. In other words, k greater than 0 but less than 32 over 9. Right? You lost me by the drawing already, bro. Okay, if I lost you by the drawing already, then genuinely, why am I watching this? I understand what. I lost you at the drawing. I thought you were saying, why am I watching this when I understand it already? It's like almost as if to say, you came onto the live and you already knew what was going on. So why are you watching it? Why are you sticking around? Okay. I thought that's what you were saying, but I guess now I understand you. Meaning you are still lost and you are lost. Okay, did you just join? Okay. Yeah, so guys, what I'm saying all in all with these questions, you are always comparing with these questions, these ones, the K questions, right? for which values of k will f of x equal to k have exactly 3 different real roots. All right. Yeah. So if really you had your line, okay, just above this stationary point, then you can see if you draw a horizontal line, it cuts through 1, 2, 3. So that's 3 roots. So that's why these blue lines indicate 1, 2, 3, 1, 2, 3. That's 3 different real roots. So you are going to have 3 different real roots between 0, that's your lowest y value, to 32/9. That is your biggest y value. Okay. Sifundo, if the question was about the parabola, they basically use the same kind of approach, but then for parabola, you would never have 3 real roots. You would have 2 at most, okay? And then you'd have 1 as well. So you'd have 1, which is exactly at the turning point. So it's only 2 and 1. And then with parabola, they sometimes will ask, where is the root, one root positive and the other one negative? And so you basically use use your line to basically indicate that. Okay, so for instance here, even they could say, where do we have exactly one root that is negative? Where do we have exactly one root that is negative? So guys, exactly one root that is negative, I mean, you can see most that we'd have to go a bit above and beyond. If where the y-intercept is, all right, where the y-intercept is, all right, you can see here, all right, what root you have. Okay, the root here will be 0, but then above, all right, that k greater than 9 here, then you start having what? One root that is negative. So one root that is negative is found at k greater than 9. Okay, yeah. Presh, you are asking about how about when f of x is equal to negative k. Presh, if let's say they had said f of x, let me just explain that. It's a good question that you're asking. I want to explain. Okay, if they had said f of x is equal to negative k, okay, then it means that everywhere where you have k for these answers that you had just mentioned, you would just in the place of y, you substitute negative k this time around. Then you solve what is given. So for instance, let's say if they had said, for which values of k is f of x equal to k having exactly 3 different real roots. Fundamentally, where you identify the place that you identify is still the same. It's no different. 3 real roots is still going to be between 0 and 32/9, isn't it, Presh? It's still going to be between 3 real roots. You are finding, if you take your ruler, okay, you know here at the stationary point exactly there are 2, but above, okay, up until the other stationary point, just before the other stationary point, you have 3 everywhere here. 3, so it's like 2 at the stationary point. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1. Does that make sense, guys? So it's like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 3, 3, 3, 3, 3, 3, 2, 1, no, 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 no. But then 1, all the ones before the k less than 9, but k greater than 32/9. there are 1, 1, 1, 1, 1, and these 1 roots are positive. But then here, the 1 root is 0. Then above k greater than 9, the 1 root is negative. Okay. All these below k less than 9, all of these roots are positive, all of them. None is negative, all are positive. Okay. So what I'm saying is that if now, don't eat your nail. Asuka. Oh, Omni, really? I mean, is that the only thing you can say? I'm sorry, I enjoy them. I've been enjoying my nails since like childhood, so I'm sorry. It's a habit that basically is, in your estimation, it's terrible, but like I just can't put it away. So oh, my Suga. I'll say it all I want. Suga, you. My goodness. This guy, what's up with you? You come here and you come and tell me stuff. But if you don't want to be here, please gravitate towards another life. I really would ask you to do that. Because you came here, okay? Okay, let's do this. Let's do this. I think you are proving to be for me. All right, let's do this. Okay, here we are. So, like I said, Fresh, you still have three real roots between, right? So your answer is still the same, all right? Still the same, still the same. But you say k, negative k, greater than what? Than 0, less than what? 32/9. You would still write that. But then since you have a negative, you are just going to do what you know you ought to do in inequalities. And that is what? You are going to divide by -1. And when that happens, what happens to the inequality sign? Changes direction. Divide by -1 here. Divide by -1 there as well. Okay, which is the same thing as times by -1. So what do you get? You get 0, k, -32/9. That is basically your answer. Okay, so basically rewritten, you can then say 32/9. That is basically what you would do. So you do that like with each situation where you have f of x is equal to -k. Or if there's another constant that exists on the other side of f of x, let's say you had f of x equal to -k plus 1, what you do, you still would say the answer lies between 0 and 32/9. Okay, and then you would substitute in this middle part the expression you have on the other side here, and then you would solve the inequality. So I hope you get the point. Okay, yeah, so guys, I am going to pull out and ship out because yeah, that's pretty much about as much as I can do today. Yeah, so I don't know if you have any other just concluding questions, because yeah, I need to bounce now. Yeah, otherwise yeah, work is still calling for me tomorrow. I have to be with it. The rest of the questions where? there are no rest of the questions for this main question, the one that's here. Okay, so there's no rest of the question here specifically. All right. Or you mean the rest of the questions from this document? I mean, I can always send you those if you want them. Is it because you want to do them on your own? I can always just send you pictures of these and then you can have them. I don't have to, you don't have, I mean, it's not a must that you must have them on here. Thank you. I barely understood inequality on cubic functions. So is that even after the session? You barely understood even after today? Or are you saying you at least understood it better? I'm just asking, Mr. Gentle Giant. Okay. All right. So I'll send you these if you want, like all the rest. Like, I mean, so this function, oh, you do now. Okay, that's awesome. So with this function, these are the questions for that function. Upload, yeah, I'll try and upload. I'll try and do that. Okay, then these are the other. So yeah, this question 8 has these questions under it. You see? Yeah, now you see this one, tangent stuff. Yeah. Not optimizing tomorrow, guys. I'm still busy with functions. Okay, cubic functions. I want to play cubic functions until, because I want to complete these questions that we have on here, right? At least, and I believe there's just a few more questions to go, because conceptually, I need you guys to conceptually understand some of these things. Okay, there we have the rest there as well. Some there as well. Okay. And then there is the conclusion. Yeah, we will be doing optimization. Don't worry. See, we have a lot of optimization questions coming. Don't worry. We are going to go there. We are going to go there. Optimization is easy peasy easy as well. All right. So like, there's nothing to it, guys. Once you understand the basics, you'll be fine. You'll see. Optimization is sweet, you know, but it needs. Let me just say this. Optimization also needs your head knowledge, your good head knowledge of measurements. If measurements sucked last year in grade 11 and also in grade 10, then that's where sometimes your troubles start with optimization. Okay, because you don't know the basics of some of those things as well. So we'll look at those tomorrow. Okay, so see you guys again, same time tomorrow. Okay, we'll do 10 p.m. until 12. Okay, okay, tomorrow. Otherwise, yeah, I'll explain these things. You'll see when we get to optimization. But for now, yeah, we're going to push this agenda. Okay, cheers, guys. Let me stop and leave you. We'll see you tomorrow. And please, guys, please, man, if you can, all right, if you are here and you come through, send me at least your hot meals. Like, daily hot meals are nice, guys. 1 rose will be enough for the life. Just 1 rose. Imagine if all 100 and something of you sent me 1 rose. That would be good enough. Or you awesome. Just one if you can. All right. Thank you so much. I'll see you guys tomorrow again, 10 p.m. All right. Cheers. Bye.